going further, the next process is called sequence activities. So what is sequence activities? I take the activity list from the previous process. Okay, this is the main input in this process. Take the list of activities, use precedence diagramming method to come out with the network diagram. Okay, of course, I need to apply the dependencies, leads and lags. These will be applied. But predominantly what I'm doing, I'm taking the list of activities, use the precedence diagramming method and arrive at the network. What is this precedence diagramming method? Okay, precedence diagramming method or PDM. This is also known as activity on node or AON. It's known as PDM or AON diagram. So what exactly is done in PDM or AON diagram? In this we have two important components. One is called a node, right? One is called a node. The second one is called as an arrow. These are the two elements in a precedence diagramming method. So this is called a node. This is called an arrow. Of course, the node will have different representations. Some places they use square, some places they use rectangle. Some people like to use a circle. So it's up to you how you want to represent it. But typically here I will be using more or less like square or rectangles. Now, what is shown in precedence diagramming method? Let's say you have two activities. Okay, you have two activities. Let's say there is an activity A. So the activity will be represented by a node. The activity is written on the node. So this is the node on which I am writing the name of the activity. That's why it's called activity on node. Let's say I have another activity. Let's say this activity is activity B. Now, if I know that activity B cannot start until activity A is completed, then I can show the relationship between these two activities by drawing an arrow between these two activities. So what it says, A must be done first, completed, then only B can start. If A is not completed, B cannot start. To give you some example, like for example, like finalize carpenter. This is the example I told you. Let's say this is finalize carpenter. This may be like install wardrobe. Now I know I cannot install the wardrobe. I cannot install the wardrobe unless I finalize the carpenter. The carpenter is important. Without carpenter, I cannot install the wardrobe. So this is the sequence shown here. A must be completed first, then B should be done. And this is called activity on node diagram. So that is precedence diagramming method. We will talk about dependency shortly. Okay, as we move, we will talk about precedence diagramming method, arrow diagramming method. Okay. So this is no more or at least this is no more preferred method anymore. So you do not need to worry about it. Just focus on this. PMBOK just talks about the precedence diagramming method only. Okay. Now the next thing we want to focus on is the 4 kinds of relationship between activities. Okay, what are the 4 kinds of relationships? We have finish to start, or it is known as FS. We have start to start, SS. finish to finish, or FF, and then finally start to finish, SF. So the relationship between two activities you can represent using any of these four relationships. Actually, the one I have showed you here is called finish to start. FAS actually. Where I have to finalize carpenter, finish finalize carpenter, and then start installing the wardrobe. Finish of A triggers the start of B. Okay, the finish of A triggers the start of B. So that is the FAS. Of course, we have three more relationships. We will see one by one. So finish to start or FAS. This is the most frequently used relationship. If you look at most of your scheduling, you go on today or tomorrow, you look at your schedule you are using, typically most of them will be FS. That is a default, okay? That is a default. In most of the softwares, you don't need to tell FS. If you just connect two activities, automatically it will take us FS. Only if you want other relationships, you need to enter the data. For FS, it's automatically taken. If you just connect two activities, it will take it as FS. One after the other, right? So if you just enter data, it will start. Once you connect, it will just, typically it will take FS. What it says a successor activity cannot start until a predecessor activity has finished. Okay, for example, development versus testing. Okay, let's say an IT project where you need to writing the code and then you need to start testing. Let's say if you show like this, what it says, the development must finish first and then you can start testing. You cannot start testing until development is finished. The same example I gave you, like you have to finish finalizing the carpenter. You need to appoint the carpenter, then only you can start installing the wardrobe. Until carpenter is finalized, you cannot install the wardrobe. So that is called finish to start. Finish one activity, then start another activity. For example, you need to finish this PMP training before you submit the application to PMI. So you cannot submit the application to PMI for PMP exam before you finish this training. So this is a prerequisite. The finish of one activity triggers the start of another activity. Now let's move to the next relationship, which is start to start relationship. Again, this is quite common. A lot of people like to use start to start. Maybe after finish to start, I believe that SS is something that's the second highest used in scheduling. So what it means here, a successor activity cannot start until a predecessor activity has started. So here we are not talking about the finish. Here we are just talking about the start. For example, I have two activities, let's say design and construction. Normally what we do, we don't wait until the 100% design is completed. Right? That's very rare, right? Like this, design 100% complete and then construction start. Very rarely happens nowadays. Normally what happens, the design starts, after a few days you want to start the construction. There is a gap. Of course, you cannot immediately start. Normally what happens is there is a gap between this and this. And then we say that, okay, maybe like, let's take, for example, this is, let's say 30 days, right? Let's say 30 days. All right, let's say 30 days. So I need 30 days. I want to give the design team 30 days. Okay, boss, I give you 30 days. Within 30 days, give me some design drawings. Right? I need to start construction. I need to start excavation. I need to start maybe like foundation. I need to start maybe like something, right? Some work I want to start. I cannot wait too long. The customer is pressurizing me. I need to start it. So I will give you 30 days. You finish design and give me some design. I will start my construction work simultaneously. You can produce more designs. So this is what normally we do in most of the projects. So this relationship is called SES, start to start. But here we are not exactly starting at the same point. It's not start to start, but start to start with a difference. There is a small difference here. How many days? 30 days difference. So this 30 days, there is a name in scheduling technology, scheduling methodology. It is called lag. So what is this called? This is called as a lag. 30 days is called as a lag. So what is lag? Lag is something called waiting time. So the construction is waiting for 30 days so that design can be ready. So that the design team can give me some useful information so I can start my construction work. Now, how do I write this relationship? In a software, I need to write this relationship. We write it as start to start plus 30 days. Okay? Start to start plus 30 days. If start to start means exactly at this point. But we are not starting exactly at this point. We are delaying it by 30 days. So that's why it's called start to start plus 30 days for the construction. So this is called start to start relationship. Now let's move further, right? Finish to finish. Okay. Let's say finish to finish. Now we are not talking about the start, we are talking about the finish. From the finish of the previous activity, how many days you need to finish the subsequent activity? Let us take, for example, in our construction, maybe like, let's take this is construction work. And then you need to provide as-built drawings. Normally, like as-built drawings, you don't wait for construction to finish to prepare the as-built drawings. Normally, like as the work completes, you might be preparing some as-built drawings earlier also. But most of the work finalizing might happen after the construction work is done. So normally, the customer might pressurize you, hey, where is the as-built drawings? When are you going to submit? Now I might say that, okay, boss, let the construction finish. From the date of completion of construction, I may take about 45 days to submit all the as-built drawings. Right? That could be something you are talking about. Right? From the completion of construction, I need 45 days to prepare the as-built drawings. So that is what is shown here in this kind of relationship. The finish of one activity triggers the finish of other activity. My as-built drawings cannot complete until all the construction is completed. If the construction is going to be delayed, as-built drawings is also going to be delayed. Whenever you complete construction, from that day, I will take another 1.5 months. That is what I am saying. Okay. From the construction, I need, like, let's say I need 45 days. Once again, the 45 days is known as the lag, the waiting time. From the completion of construction, I am waiting for 45 days to complete the as-built drawings. Now, how do you write this relationship? You write it as finish to finish plus 45 days. Finish to finish is exactly this line. From this line, I take another 45 days. FF plus 45 days. So these are the three kinds of relationship that are used regularly. FS is the most highly used. Almost like 90% of activities we like to use FS. SS is also quite highly used. FF is slightly lesser, not so much, but still, yeah, people use it. It all depends on the scheduler, right? Sometimes some scheduling people doesn't like FF completely, then they may not use at all. But some people like FF, they may use FF. Let's move to the last one. The last one is known as start to finish. It's a very, very rarely used relationship. I have not seen the projects where I have worked people using SF, or at least I have not noticed SF so far in my projects. So what is SF? SF is slightly a confusing concept or slightly difficult concept to understand. Now what it says actually, the first activity is happening, right? The first activity keep on continuing. Now the first activity cannot stop, or the first activity cannot be finished until the second activity has started, right? If second activity is not started, if second activity gets delayed, the first activity cannot stop. So it's a slightly different concept. It's slightly difficult to understand. Maybe I will give you a simple example. Let's take, for example, maybe your office building. You are living in an office building, or you are working in an office building. Typically, if you see, most of the office buildings will have security guard. Okay, most of the buildings. And these security guards will be working in two shifts normally. There will be a morning shift, there will be an evening shift. So the morning shift normally like 7 a.m. to 7 p.m. is the morning shift. The night shift will be like 7 p.m. to the next day morning 7 a.m. Now let's say the first shift, the guy is working. He started at 7 a.m. Now it's coming close to 7 p.m. He's getting ready to close his work, getting ready to finish his work. But now at around 7 o'clock, he gets a call from his friend, right? The second shift guy who is supposed to come. He calls and then say, hey, sorry, yeah, I'm late today. Right? I went to the clinic, and then in the clinic, there is a long queue. I need to wait for probably, it seems like it may take another 30-45 minutes to see the doctor. So can you please wait for me? Right? Now this guy, the first guy cannot finish his job. The predecessor cannot finish. The first person cannot finish. Why? The second person is still not ready. The second person has not taken over. Normally the protocol is you cannot leave the building unattended. You cannot leave the building without any security guard. That is normally the protocol. So this guy had to stay. So he's waiting, 7 o'clock, 7:15, he continues the work. 7:30, he continues. 7:45, right? So he's continuing his duty. And then suddenly 7:45, that guy running, keep coming and then say, hey, sorry. Right? I just came. Give me 5 minutes. Let me change my dress, change to uniform and come. So he runs inside, changes his dress and comes about 7:50, 7:55. So now this guy hands over. The second shift starts. The second shift guy has taken over. Then the first guy stops and leave the project. Okay. You understand what is happening here? This is not finished to start. Typically, we want finish to start, but sometimes it's start to finish. Unless the second shift starts, the first shift cannot stop. Maybe like where we have some, say, old buildings and you are constructing a new building. you cannot like stop using the old buildings unless the new building is ready. So some kind of concept like that. In case the new building gets delay, then people still have to be there. Originally, you might have planned that, okay, 1st January, we all want to move to the new building. But you look at 1st January, the building is not ready yet. So you have to tell the team, okay, team, still the building is not ready. You have to still stay in this office. Maybe like another 1 month goes. Okay, 1st February. Now they are saying, okay, now you can all move to the new building. So now you stop, maybe like you are paying rent for the old building or something, you have to stop now. You cannot stop it until the second building is ready. So once the new building is ready, you shift everybody, then you stop the rent, you stop the water, you stop the electricity, right? Whatever you want, you can stop it. Until the new thing started, you cannot stop all this. So this is slightly different from finish to start. Even though sometimes we might misunderstand finish to start and start to finish as almost the same, but they are not same. In finish to start, we don't care what happens with the successor. Whether the successor starts or not, I don't care. I just finish my activity. I finish, I go. Like for example, the design drawings, if it is finished, this team will move. I don't care whether you start construction or not. I might finish the building, hand over to the customer. I don't care whether he moves in or not. That is his problem. I don't care. Right? So that is finish to start. So in finish to start, we don't care. We finish our activity, hand it over, and then we move on. We don't care what happens to the next activity. Whereas in start to finish, we wait for that guy to start. If that guy doesn't start, the second activity doesn't start, I don't stop my work. I keep on continuing. Okay, so this is the 4 kinds of relationships you need to know. Any doubts in this? Any confusion with the 4 relationships?
No.
Okay, right. So let's move on further. Now there are something called mandatory dependency and discretionary dependency. Right now we have, so far we are talking about the dependencies like finish to start, start to start, all those. Now these dependencies could be either mandatory or discretionary. Let me give you an example what is mandatory, what is discretionary. Right, let's say we have 2 activities. Right? Let's say the first activity is, let's say I need to construct a wall. Right? Let me say I need to construct a wall. And then the second activity, let's say, is to paint the wall. Okay, the first activity is construct a wall. The second activity is paint the wall. Now, what sequence should I do this? Which activity should I do first? Can I do painting the wall first? Or can I do simultaneously? Which activity should go first?
Construct the wall.
Construct the wall, right? Naturally, right? Without the wall, you cannot paint, right? சுவர் இல்லாம சித்திரம் வரைய முடியாதுன்னு சொல்லுவாங்களா அது மாதிரி unless the wall is there, you cannot paint it. There is no way you can paint it. So this relationship is called mandatory relationship. You cannot change it. Whether it is a new person, right, junior person, or a person with 25 years experience, he cannot change it. He has to follow that. This is mandatory. The sequence has to be this way. I need to construct the wall, then only I can paint the wall. I cannot paint the wall first. If the wall is not there, I cannot paint it. This is in nature. This is inherent in the work. Right? In most of the projects, like for example, constructing the column, Unless the foundation is there, you cannot construct the column. Unless the column is there, you may not be able to construct the slab. Okay, there are certain special categories are there, but let's not go into that. Okay. So typically like first floor, second floor, third floor, fourth floor, right? So that becomes a mandatory dependency. You cannot change it. Or sometimes there might be a legal requirement. For example, before you start construction, you need to get the planning permit approved by the planning authority. So that is again a mandatory dependency. If you don't get the planning permit, you should not start. If you start, it is illegal. Maybe the government can come and demolish the building. So maybe that's a mandatory dependency. Now let's look at some other example. Right? Let's take again the same right, the same example. Now let's say I need to paint the walls. Let's say the entire room I need to paint the walls. And I also have another activity which is like lay the carpet. Okay, lay the carpet. Okay, for the room, the entire room, I want to lay the carpet. The first activity I want to paint the walls. The second activity I want to lay the carpet. Now, which activity should go first in this? Should I paint the wall first or should I lay the carpet first? Or can I do simultaneously? Which is the sequence?
Paint the wall.
Paint the wall first and then you want to lay the carpet. Okay. That's okay. Fine. But can I not do this way? Is there any problem in doing this way? Can I not lay the carpet and paint the walls? Is there a problem?
Can be done, but we need to protect.
Exactly. Right. So it can be done. It's not that it cannot be done, or it's not that mandatory that I must do it this way. But this is a good practice. Painting the wall first, clean the room, get the painter out, then lay the carpet is a good practice. That is what my experience tells me. That is what my common sense tells me. Because otherwise I might damage the carpet. I might unnecessarily have some rework. But this is not mandatory. I can still do it this way, nothing wrong. Okay, nobody can question me. If I have some protection measures, maybe like I place some plastic sheet on top, or something like that, right? Or maybe I put one more supervisor closely monitor. But it can be done. It's not that it cannot be done, but it is preferred to be done this way. People prefer it this way. This way, it's less headache. You need less supervision. You have less chances of rework. So this is called discretionary dependency. The first one is called mandatory. I cannot change it. Nobody can change it. The second one is called discretionary, at my discretion. If I want, I can plan it this way. If I want the other way also, I can plan it. I can also do it simultaneously. Also, I can do it. Nothing wrong. But this is my discretion. I prefer to do it this way. Right? So this is the difference between mandatory dependency and discretionary dependency. And you can also have internal dependency and external dependency. So what is internal dependency? All these we are talking about are all internal dependency within the project. Construct the wall, paint the wall, lay the carpet, construct the foundation, construct the column. Right? All these are internal dependencies. What is external dependency? Maybe like waiting for approval from the government, waiting for the approval from consultant, waiting for approval from the customer. You have done a mock-up, you need an approval from the customer. You are waiting for external people to give you approval. So that is called external dependency. Sometimes you are waiting for the land to be handed over to you, the building to be vacated to you, and then you can demolish it. So these are all external dependencies. So in your project, you can have most of the dependencies will be internal, but you also will have certain external dependencies. And you can have a combination of these four, like mandatory external, like getting a planning permit from government agency is a mandatory external. Mandatory internal, right? This is constructing the wall, painting the wall is a mandatory internal. Discretionary external. Sometimes like the customer may not ask you to get the approval for something, right? They may say it's okay, you can go ahead, but you want to get the approval. You want to do a mock-up. You want to show it to him. Boss, I think it's better you take a look before we go further. The customer might say, it's okay, Manik, you can go ahead, but I am not confident. I'm worried later customer might come and find some faults. Maybe I want to do a mock-up. I want to show it to him. Boss, this is how it's going to look like. Better you take a look at it. If you have any comments, let me know now. Right? I cannot rectify later. I want to avoid defects later. That is discretionary external. Discretionary internal, like for example, this is discretionary internal. So you can have 4 different kinds of dependencies in your project. Now lead and lag. So what is lead? What is lag? Lag is waiting time, right? As we have seen before, some examples I showed you. Lag is the waiting time. How much time you need to wait before the second activity can start? Like for example, I start the design, I wait for 30 days to start the construction. That is lag. Sometimes I might say that finish construction, and from the finish of construction, I need 45 days to submit the as-built drawings. That is again lag, 45 days lag. Or maybe like normally like you might be like doing a concrete slab, concrete is done, and then I want to wait for 14 days before I start any activity on top of it. That again is a lag, a waiting time of 14 days. So lag is very, very common in most of the projects. But sometimes you also have something called lead. Lead is very rarely used, but you can use lead also in some projects. For example, here, complete punch list, landscape the building, right? So here where you might start completing the punch list of your building, but you don't want to wait until all the snags are rectified. So maybe after you start completing the punch list, if you know that it's going to complete maybe like end of the month, so you don't wait for that. Maybe like 2 weeks earlier, you want to start your landscaping work, because you know that most of the building work is completed, is mostly is acceptable to the customer. Very little work is left over. So you can start the landscaping. We don't wait for everything to complete. So this is called a lead, where you are taking a lead. You are not waiting until the completion. You are going in front, right? You are going 2 weeks in front. So this is called lead, and this is written like this. Okay, how do you write it? You write this relationship as FS minus 2 weeks. Okay, always when we write lag, it is plus SS plus 15 days. Okay, in this example, you are writing the draft, and then after 15 days, you are starting to edit the draft. This is SS plus 15 days. Whereas here, it is FS minus 2 weeks. So lead is always negative value, lag is always positive value. While lag is going to add the total duration of the project. Your total duration of the project is going to increase. Lead is going to reduce the duration of the project. So this is lead and lag. So at the end of this process, what do you get actually is you get a network diagram like this. Okay. This is a kind of network diagram where it shows the various activities and how they are connected. Okay. And the various path available in the project. Right. That is what we are talking about here.